Welcome to The Explainer. Today, we're going to pull back the curtain on AI. We're talking about the supposed magic behind these big language models, and we're going to follow the exact path your words take, right from when you type them in.
So, you've probably played around with an AI chatbot, right? You type in a question, and bam, you get this response that sounds, well, pretty human. But have you ever stopped to think about what's really going on in that tiny moment after you press enter? Well, here's the thing. It's not magic at all. It's actually a prediction game, and a surprisingly simple one at its core. You see, a large language model, an LLM, is really just built to do one job: predict the next word. Seriously, that's it. Everything these models can do, it all stems from that one simple but incredibly powerful concept. So let's start with this big idea, thinking of it as a prediction machine. For a minute, just forget all the talk about intelligence. At its very heart, an LLM has just one job. You can almost picture it as this ridiculously complex machine, right? It's got millions of little knobs and levers. In the real world, we call them weights. And they've all been tweaked and tuned over and over again, all to get this prediction game down perfectly.
Okay, so for example, what happens if you give it the classic phrase, once upon a... The model's entire mission at that point is to figure out the most probable next word. And you guessed it, it's almost always going to be time.
But here's the catch. Machines don't get words. They only speak the language of numbers. So the very first step in this whole process has to be translation.
All right, let's really get into it. We're going to take a super simple prompt. The cat sat on the, and we're going to follow it step by step right through the guts of the model. First up is something called tokenization. The model basically looks at our sentence and breaks it down into smaller chunks, or tokens, using this massive internal dictionary. So for us, the, cat, sat, on, and the each get turned into their own unique token.
Okay, next, each one of those tokens has to be turned into numbers the computer can actually crunch. This step is called embedding. And for the specific model we're looking at here, every single token gets transformed into a list of 288 numbers. That big list of numbers, that's how the machine mathematically understands the meaning of that token.
So now our prompt isn't words anymore. It's a series of number lists. And now it's ready to start its real journey, deep into the core of the model, through a whole bunch of processing layers.
This trip through the model has a name. It's called the forward pass. Basically, our numbers get sent through stage after stage, and with each one, the model's understanding gets a little bit deeper, bringing it closer and closer to that final prediction.
Now, the model we're exploring from the source material, it has 6 of these layers. You can really think of each layer as another chance for the model to, well, think about the prompt, to process it a little more. And here's what's cool. Inside every single one of those 6 layers, the data goes through 2 main steps. But it's that first one, the attention mechanism, that's the real game changer. This is the idea that basically made all of modern AI possible. Which brings us to the secret sauce. Seriously, this concept is so important, it's really the core of how this all works. Let's talk about the art of attention.
And hey, don't just take my word for it. The source material points out that the entire LLM revolution basically exploded from one single research paper. Its title? Attention is all you need. That's how big of a deal this is.
So what is attention really? It's just a way for the model to look back at the prompt and decide which words matter most. Think about our sentence, the cat sat on the. To predict the next word, the model has to figure out that cat and sat are way more important clues than the word the.
This is a really great way to think about how it works. The model basically asks 3 questions. First, the query, which is like asking, what am I looking for right now? Then it looks at all the past words and asks about their keys, which is like saying, what kind of info do you have? And based on how well the keys match the query, it decides how much attention to pay to the values, the actual meaning of those past words.
And it gets even cooler. The model doesn't just have one attention mechanism. It has multiple heads running at the same time. You can think of it like one head is looking at grammar, another is tracking pronouns, and so on. Plus, there's this really clever math trick called rope, which helps the model understand the order of the words. I mean, knowing that cat came before sat is pretty crucial, right?
All right, let's recap. Our little prompt has been chopped up into tokens, turned into numbers, and it's passed through all 6 layers of deep thinking and attention. So now, what happens? The model is finally ready to make its prediction.
But here's the thing. It doesn't just spit out one word. The final output is this enormous list of scores called logits. We're talking a list of 32,000 numbers here. There's one score for every single token the model has ever learned, and each score represents how likely that token is to be the next one.
And after all that work, this is what it boils down to. You get a clear winner. You can see right here that the score for the token Matt is super high, while the scores for words that don't make any sense, like sky or idea, are basically at 0. The choice is obvious.
So what does the model do? Simple. It just picks the token with the highest score, turns that token back into a word, Matt in our case, and tacks it onto the end of the sentence. And just like that, our prompt is now, the cat sat on the mat.
And that's the entire journey, from prompt to prediction. It's not magic, it's just a process. And when you see an AI write a whole paragraph, all it's doing is running this exact same journey again and again and again, with each new word it generates becoming part of the prompt for the next one. Which leaves us with a really fascinating, kind of mind-bending question. Think about it. This whole system, which can write poetry or even code, is really just a prediction machine. It's just guessing what comes next. So, if that's all it takes to do what it does, what does that say about how our own brains work?